Okay, so we are Bismillah. Okay, welcome back. So we just restarted question number 6. Marcus and Davina are finding out about the water cycle. They make the mini garden below to observe how water can change. So they follow steps 1. Put a layer of soil in the bottom of a clay bowl. Add a small plant and water it well. Cover the bowl with plastic wrap. This is the mini garden. Put the mini garden on a windowsill. But the first part says the plant needs water to grow. Name the part of the plant that takes in water from the soil. Put your hands up only. Do not scream in the lesson. Okay, right. So I want everybody to think about it. See which person has to put the hand up and choose them. Okay. You should all know that. A plant takes in the water. Please don't say it from the leaves. From the? Okay, excellent. Well done. You did still shout at it. Okay, so we call it the roots. So let's write that down nice and clearly. I'll get my pen ready. Okay. From the roots. Okay. Or we can have like root hairs. Roots is fine. Okay, lovely. Next part B. In the mini garden, water changes to water vapor. What is the scientific name for the process in which water changes into water vapor? Don't shout out. Okay, let's have somebody different this time. You have to be quiet. So we have water, for example, in a room or in a cup, and then it goes into the room. It's like gets less and less. We say the water has something. The water has dissolved is something different. Not go on, Salia. No, not drowned. Okay, no, okay. Okay, so the answer given to me by Arwa is the process when water turns into water vapor, into a gas, is called evaporation. Okay. Evaporation. Okay, so that's nice, 2 straightforward answers on question number 6. Are we all happy with that? Yeah. So we all know that the water in a plant is absorbed through the roots or root hairs. Okay, any of those answers is perfectly fine. Okay, and we know that when the water turns from water into water vapor is like a gas goes into the air. That process is called evaporation. So if you leave your clothes in the room and you come back as nice and they were wet, now they are dry, this water has evaporated from your clothes. Okay, lovely. Alright. Okay, so the water vapor cannot escape from the mini. Oh, I think we need to start back over here. Okay. Done. That's why it's important that the mini garden has to be well sealed. So stop the water vapor from escaping from the mini garden. Lovely. Beautiful. Nice answer. Okay, question part D now. It says Marcus and Davina can observe all the changes in the water cycle in their mini garden. This is the diagram of the water cycle. This is like the real water cycle. Draw 4 lines to match each letter A, B, C and D to the correct description of what is happening in the water cycle. Okay, so give me one moment while I grab a line. Okay, now. Okay, let's have a look at A. Which part is A? Okay, put your hands up please and tell me. Look at the diagram. We've got water from the lakes now going into the air. What do you call it when the water changes from water and it goes into like a gas, it goes into the air? We just mentioned that in the previous question, on the previous part. So part A is what's happening. The water is doing what? Is changing from water into. So which one is going to be? Which one? Which description? The second one. Well done. So these two are connected. So water here, if you look at part A over here, water is changing into water vapor, i.e. it's changing into gas. That's part A then. What's happening in part B? When the water vapor rises, it changes. So it was water. It was water, then it becomes a gas, then it goes back into becoming water again. So B is where? What's B? Water vapor changes. You should really say changes back into water. Lovely. You do that one. So part C. Let's look at part C now. So now that the water is coming back down. So what's part C then? Go on. The rain falls. So, hang on a second, hang on. You're rushing ahead. You just shout your answers. So, C is the rainfall. If you look here, from the clouds, rain's coming down. And D is the easy one. It's the last one left. So, the water is flowing into the lakes of C, which is down here. Done. But you have to be careful and think through what's happening there. Lovely. Question number 7 now. Class 6, this is called heating rods. Class 6 are investigating how long it takes heat to travel along rods made from different materials. What scientific name is given to materials that allow heat to travel along them? If anybody gives me the right word, I will be duly impressed. Okay. So if heat can travel through an item easily or travel through it, what do we call that? What do we call that scientific name? That when the material allows the heat to go through it. We say the material is begins with C. It is a conductor. What do we say? We say the material is a conductor. Okay, the proper word for it is, if you want to use the word heat in it, is called a thermal conductor. Thermals do the heat. So it's a thermal conductor. So a thermal conductor is the more scientific word for it. If you write down just conductor or it conducts, you will still get the result answer right. But the thermal conductor is a more proper and fuller answer. Yeah? Thermal conductor is to do with heat traveling. Yeah? So people say, oh, I've got my thermals on. They're talking about the gloves. My thermal hat on. I've got my thermal gloves on. So the gloves that keep the heat in. Yeah? Ah. So you have thermal conductors and thermal insulators. Insulators keep the heat in. Conductors allow the heat to travel through it. Okay. Just as a quick side thing. Now, if I have a pan, which I'm going to make some tea in. Yeah? A pan that I'm going to make tea in. Is that a thermal conductor or is it a thermal insulator? Thermal conductor. Because it allows the heat to go through quickly and warm with water. Okay, now let me give you a different example. I have some gloves. Is that thermal conductor or thermal insulator? Thermal insulator, because it keeps the heat in your hand, stops it from escaping. Okay. You have a wooden spoon that your mom uses for making the pot, so she doesn't burn her hands. Is that thermal insulator or thermal conductor? Thermal insulator, because it protects her hand from the heat traveling through it. Excellent. Well done. Yeah? Good. Alright, next question. Question 7, part B. Class 6, push a paper clip into some wax. So here's a rod, there's the wax on and the paper clip in the diagram. You can see over here as well on the screen. Because the candle heats up the rod. The heat travels along the rod to the wax. When the wax melts, the paper clip falls off. Class 6 measures the time it takes for the paper clip to fall off. What force causes the paper clip to fall into the tray? Easy one, go on, Rian. No, well, what causes the paper clip to fall down?
The wax. The wax melting.
No, that's not a force. What causes it? Shh, quiet. What causes anything to fall down? And you got it. For question 7, part B is gravity. Gravity is the force. You can write an answer like gravitational attraction. Okay, gravity. What force causes the paper to fall into? So gravity is allowed. Gravitational attraction is the preferred answer. So let's write that underneath in a different color.
Attraction. Gravitational what?
Yeah. Okay, are we happy with that, folks?
Yeah.
So that's the name of the force that caused the paperclip to fall down. Okay, are you ready to move on to the next page now? Yeah? Okay, right, here we go. Okay, well, question part C. Class 6, record the results in a table. Fill in the missing heading on the table of results. Now, the time taken for paperclips to drop in seconds is the second column. The first column, okay, Mr. Kamal, what is the title missing in the first column? Nobody else, please, everybody's quiet. Mr. Kamal is going to give us some information here. What should be there? We got steel, glass, and copper. What would you? So what would that be? That would be called
Material.
materials. Well done. Okay, materials. What material? Type of material. Okay, that's the material that we had. Lovely. Okay, right, Mr. Isam, can we please cut out the? Yeah. Yeah, we are going there. Okay, the heat traveled along the rods at different speeds. Put the materials in order to show how quickly heat travels along them. Write copper, glass or steel in each box. Okay. Now, which one had the heat travel the slowest? Slow on this side and quick on this side. Which was the slowest one? The slowest one, if you look over here, is glass, which took 280 seconds. So over here, we can write in here, what we write? Glass. So glass took the most amount of time, so it is the slowest. Okay, so heat travels slowly through the glass. Okay, which was the next one after glass? The one so glass are the highest numbers. The next one was steel. So steel goes here. Okay, can you write this down, please? So steel was the next. Now, which one was the quickest one then? Yeah. Copper was the quickest because it had the smallest or the least amount of time, yeah? So that was going to be copper. Okay, right. Mr. Isam, have you copied down those 3 words?
Yes.
Already?
Yes, sir.
Good, well done. Okay, how could class 6 make sure their results are reliable? What should they do? How do we make sure a scientific experiment is reliable? Go on, Hannah.
Check it 2 times.
Oh, good. So you repeat the test,
Double check.
do the test again. Excellent. Or you do more than once in there. So repeat the test.
So repetition. Double check.
Okay, so what we do here is change color again. Okay. So we should. So here we should repeat the test. We should repeat. Or do the test again, or do the test 3 times or more than, okay? But that will do. Okay. Look at the table again. Write true or false next to each statement about class 6's investigation. The heat traveled quicker along the metal rod than along the glass rods. Is that true or is that false?
True.
No, that is absolutely true. So let's write that down. Let's change color on this. Hang on a second.
I'm just going to keep it and close the
No, you have to write down true. You can't tick it for true because it says true or false. You got to write down true for true and false for false. Okay?
That's how I hate having that. False, is it?
Okay, next question. The one variable class 6 changed was the time it took the paperclip to fall off. Is that true? Did they change the time?
No.
That's not variable to change. So that's completely false.
Like I said, I'm true for the last.
Okay. Can we actually read the question first and think about it?
Yeah.
Rather than just give us the answers, yeah? The one variable class 6 measured was the temperature of each rod. Did they measure the temperature of each rod?
Yeah. No.
No, they didn't. So that is also false.
What was the measure of the temperature?
They didn't measure it. Now that is the end of question number 7. All of 7 is done.
Can you do the next one and then go out to break? No.
Okay, yeah, inshallah. Let's do then, yeah? Question number 8. The sun. George makes a model of the sun, earth and moon. He uses 2 bread rolls and a 50p coin. Okay. Here's the sun here, that's the moon, that's the earth. The tick 3 boxes show some changes that would make George's model more accurate. So now, what about the sun compared to the moon and the earth? Should the sun be bigger?
Yeah.
Much bigger. So what do we put here?
Gigantic teeth.
Hang on 1 second, let me get my pen. If I can find it. No, it's the same size as the earth.
It's maybe over there on the big box.
It is. So that is absolutely true. Oh, what was that? Wonky tick. Okay, what about the moon should be the same size as the earth, is that right? No, moon is small compared to the earth. The sun should be a sphere.
Never.
What's that one? Is that right or wrong? So they're saying the sun should be like a ball.
No.
The sun is not a ball.
No. It is.
In real life.
It's not sphere.
Okay, the moon should be an oval.
No.
No. The sun should orbit the earth.
Cylinder.
The sun should orbit the earth.
No.
The moon should be closer to the earth.
Yes.
Okay, now that's 2 marks. You're going to get all 3 ticks in the right place with 2 marks. Are we happy with that? Yeah? Okay, next one. The sun appears to move across the sky each day.
It's not the sun.
Okay, sun appears to move across the sky each day. What movement in space makes the sun appear to move across the sky each day? So what's actually causing it to look as though the sun is moving? What's happening? Okay, go on.
The earth is moving.
The earth is what's happening. So the earth spins on its own axis.
So it spins slow.
That's right.
So it's revolving.
So the earth
Spins very slow.
So you can write rotate, spins, turns, moves, any of those words. Revolving as well, yeah? So the earth spins,
on its axis.
the earth spins on its axis. That's the end of this paper. Thank you very much, folks, for coming along with us. Now it's time for a break, okay?